started streaming, and I will also share this. Hmm. Yay! Thank you. Ana uta na camera. Bye. ठीक है for open R1 for student blah blah blah. So welcome to an exciting journey world of open source AI. Reinforcement is chapter designed for student understanding learning and growth. We will also explore open R1 complex concepts. LLM have shown excellent. They struggle to deal with puzzles or math problems that require multiple steps of reasoning. Reason, reinforcement, think. So here there is not just output, but there are thoughts. Let's take a look. How many pieces of fruits do I have in dough? All right, all excited?
Always.
So, what is reinforcement learning? There is a separate course, वैसे, but apparently it is not there. This page will give you a friendly and clear introduction to RL. Imagine you're training a dog. You want to teach it to sit. You might say sit, and then if the dog sits, you give it a treat and praise. If the dog doesn't, you might gently guide it or just try again. Associate sitting with positive reward. Instead of a dog, we have a language model or an agent. Instead of you, we have an environment that gives the feedback. Agent takes an action based on current policy. Environment gives a reward or penalty. Agent updates its penalty based on reward. Repeat. Let's break down. This is the learner. In LLM, the LLM itself becomes an agent. If you want to train the agent, is one making decisions and learning. This is the world agent lives in. The user interacts with the similar scenario, so we set it up for it. The environment provides the feedback for the agent. So for LLM, the environment could be the user is interacting with other scenarios. Similarity scenario is working on. These are the choices the agent can make in the design. An agent could be generating words in a sentence, choosing which answer to give to a question. deciding how to respond. Rewards are usually numbers. Policy. This is agent's strategy for choosing actions. Right? In RL, the policy is what we are really trying to learn and improve. A set of rules or a function that tells agent what actions to take in different situations. Initially, the policy might be random, but as the agent learns, the policy becomes better at choosing. Drive. Is this a road? Yes. Is this clear? Yes. Drive. No, stop driving. No, stop driving. Reinforcement learning happens through a process of trial and error. So this is a trial and error. So agent observes the environment. Agent takes in information about its current state and surrounding. Agent takes an action based on its current policy. Using its learned policy, agent decides what to do next. The environment gives agent a feedback, reward. The agent receives feedback on how good or bad his action was. Updates its policy. The agent adjusts its strategy, reinforcing actions that led to high reward. Reinforcing actions that led to high rewards. And this cycle continues. Role of RL in language model. Just being fluent isn't enough. We want LLMs to be more than just good at stringing words together. So the supervised training we saw earlier is excellent at producing structured outputs, like a chat assistant. It can still be less effective at producing harmless, helpful, and aligned responses. Might generate fluent and structured thing that is factually incorrect, biased, or doesn't really answer the user's question. And here is where it is like giving her LLM Doc extra training to become well behaved. RLHF. And we use human feedback as a proxy for reward signal in RL. We might ask humans to compare different responses generated by the LLM for the same input prompt and tell us which responses they prefer. For example, we might show a human two different answers to the question, what is the capital of France, and ask them which answer is better. We use this human preferences data to train a separate model called as reward model. This reward model learns to predict what kind of responses humans will prefer. It learns to score responses based on helpfulness, harmlessness, and alignment with human preference. Fine-tune LLM with RL. Now we use the reward model as an environment. For our LLM agent, the LLM generates responses, and the reward model scores these responses. In a sense, we are training the LLM to produce text that our reward model thinks is good, which it learned from human preferences. Get human preferences, reward model, preference data, or reward function, whatever you might want to call it. But this is trained, and this becomes an environment which rewards your target LLM, and then you use that to fine tune with RL and generate preferred responses. Why is this going back again? मुझे लगा कि ये इंडिपेंडेंटली एक 10,000 15,000 रिस्पॉन्सेस देगा और ये क्वेश्चन पूछेगा और रिपोर्ट देगा. From a general perspective, let's look at the benefit of using RL. Improved control. RM allows us to have control over the kind of data we can there's more enhance and human values. Align RM with complex and subjective human preferences. It is hard to write down rules for what makes a good answer, but humans can easily judge and compare responses. RL can be used to reduce negative behavior in analysis, generating toxic languages, spreading misinformation, exhibiting biases. By designing rewards that penalize where we can nudge the moral reward. Has been used to train many of the most popular models such as OpenAI, GPT-4. These are a wide range of techniques for analysis with varying degree of complexity. In this short, we will focus on GRPO, which is a technique for analysis shown to be effective at training and helpful in aligning with human preference. Group relative policy optimization. These are let's briefly consider two of the other popular techniques, PPO and DPO. Proximal policy optimization, one of the first highly effective techniques. It uses a policy gradient method to update the policy based on reward direct design for separate reward model. So you don't need a separate reward model in DPO. Using preferences data directly, essentially framing the problem as a classification task between the chosen region. In their own right. Unlike this, GRPO groups similar samples together and compares them as a group. The group-based approach provides more stable gradient and better conversion properties compared to the other. It does not use preference data like DPO, but instead compares groups of similar samples using a reward signal from a model or a function. It compares groups of similar samples. GRPO flexible in how it obtains reward signals. It can work with reward model, but doesn't strictly require one. This is because GRPO can incorporate results from any function or model that can evaluate the quality of responses. For example, we could use a length function to reward shorter responses, a mathematical solver to verify solution correctness. And like code, I guess, or a factual correctness function to reward responses that are more factually correct. What are the key components of reinforcement learning? What is the main advantage of RLHF for training language models? I mean, no brainer है इसलिए मैं discuss नहीं कर रहा हूँ ज़्यादा. In the context of RL for LLMs, what represents an action? What is the role of reward in RL? In RL training of language models. It measures vocabulary size, blah blah blah. It provides feedback on how well model responds align with desired behavior. What is the reward in context of RL? It's a numerical score function there. Model कुछ उस पर और डिस्कस करना था या लेट्स मूव डायरेक्टली.
ये डीप सीक का इसने कुछ दिया है क्या?
हाँ उसी पे है अभी.
ये नेक्स्ट वाला है क्या?
हाँ
you can move ahead. काफी सिंपल था इसका पहले. I thought I missed this, like what you are showing on screen now.
No, that is the we are coming at now.
Yeah.
GRPO I think वो उसके context में define कर रहा है. So DeepSeek Arm represents significant advancements in language model training, particularly in developing reasoning capabilities through reinforcement learning. This paper introduces algorithm called GRPO. we introduced our first generation reasoning model, DeepSeek R10 and DeepSeek R10. Without a model to my large scale reinforcement learning without SFT as a brain inserting a transformer. Whether pure reinforcement learning could develop reasoning capabilities without supervised fine tuning. Up until that point, all popular LLMs require some supervised fine tuning. इन्होंने fine tuning की ही नहीं क्या?
हाँ.
I thought fine
Their
tuning.
whole thing was, we will do, like, we will replace fine tuning completely with RL.
I thought fine tuning was to align कि वो असिस्टेंट वाली पर्सनालिटी देने के लिए, और फिर रीइंफोर्समेंट लर्निंग से कौन से आंसर हार्मफुल नहीं है, हर्टफुल नहीं है, वगैरह वगैरह, वो सब एसएफटी से नहीं होते थे. बट इसमें लग रहा है कि दोनों को उसने एक साथ ही कर दिया.
हाँ.
Only makes sense, I guess. One of the most remarkable discoveries in Arvin Zero's training was the emergence of a phenomenon known as this phenomenon is somewhat similar to how humans experience certain realization while one of them is in the initial attempt. This breakthrough resonates with the learners. It feels like Eureka moment. It demonstrates learning rather than mere memorization. So let's take a easiest way to is to take action. If you want to try, we can also DeepSeek AI. Tell me a joke about calculus. Let's get started. When I know, then let me think about what calculus involves. Some positions. Maybe I can say. ये दिख रहा है ना? I don't know. That is not quite funny.
नहीं, उसका रिवॉर्ड मॉडल क्लियर नहीं है, मतलब व्हेन डज इट नो समथिंग इज फनी, वी हैव टू टेल इट ना.
अरे ये कैसे? अच्छा, ये उसका आंसर है. 143 सेकंड तक उसने सोचा भाई. क्लियरली बाकी सब है, उसमें कॉमेडिक टाइमिंग नहीं है. आज जोक बोलने के लिए बोला तो वो कल बोलता है. Why did calculus need a new notebook? Because they kept approaching the limits of the old one. Good, good, good. So both are available. Approaching the limits is more action oriented. I think
This is not a great example because humor is so nuanced, and I don't know if it really gets humor, or we can define a reward model for humor unless we have excessive human feedback. Mm. और क्या उसने 2-3 एग्जाम्पल और क्या दिए थे पूछने के लिए जो इसमें नहीं चले थे?
what is the capital of Pakistan?
ये तो फैक्ट है. ठीक है. इसमें रीइंफोर्समेंट लर्निंग की जरूरत पड़ेगी.
When you have a hammer, all you see is nails.
ये तो इसको जबरदस्ती ट्रेन किया है कि भाई ये सोच के दिखा है हर चीज.
Yeah, I think it's a reasoning model. या फिर वो रीजनिंग मोड में डालते हैं तो वो दूसरा पाथ लेता होगा कि हर चीज़ सोच के बोलता होगा, जो कि सिस्टम 1 ब्रेन का भी अगर बात हो तो भी वो सिस्टम 2 तक जाता होगा बिकॉज ऑफ द मोड प्रोबेबली. आई एम श्योर कि डीप सीक के दूसरे किसी मॉडल को पूछूंगा यही क्वेश्चन तो वो नहीं बताएगा. Training process. Training RNA is a multi-phase process. Let's break down phases in the key innovation. Purely. This R10 जिसमें
R10 में प्योर रीइंफोर्समेंट लर्निंग था, बट R1 में SFT प्लस आ रहे हैं.
राइट. उससे 8% 9% का माइलेज और लाया वाला कुछ था.
ये AIME क्या है?
पता नहीं. Strong reasoning but readability issues. हाँ, ये कह रहा था मैं कि वो चैट टेम्पलेट वगैरह एक पर्सनालिटी और रीडेबिलिटी टेम्पलेट उसको ये देता था ना, कंसिस्टेंसी. Cold start phase, reasoning, oral phase, rejection, sampling phase, and diverse oral phase. Unstable cold start phase of oral training from the base model. R10 पे सैंपल ले रहा है टू फाइन ट्यून. An SFT phase, reasoning RL capability building. And this is the main phase looks like, right? Capability building. So, group formation, creating multiple solutions. The first step in GRP is remarkably intuitive. When given a prompt, the model doesn't just give one response. Instead, it creates multiple attempts at solving the same problem, usually 4, 8, 16. Right? And that is what we see. मतलब कैपिटल भी पूछेंगे तो 10 चीज़ें ट्राई करेगा. Imagine you're teaching a model to solve a math problem. Question about counting chickens on a farm, the model might generate several different solutions. One solution might break down the problem step by step. It's counting chickens and subtracting roosters and finally accounting for another might use different but equally valid. Initial input, model generates the outputs, and there is a group a response aggregated and that is evaluated.
remind me, how does this go back to changing the model itself?
Guessing the weights are still trainable in this case, right? Of course, ये सब सैम्पल इनपुट्स उतने ज़्यादा नहीं होंगे इंटरनेट स्केल पे, तो ट्रेनिंग फास्ट हो जाएगा. बट आई गेस वेदर इट वाज एसएफटी और दिस, it is the weights that are still getting updated.
Mhm.
So what makes this approach particularly clever is how it handles scoring. Instead of just giving out absolute scores, GRPO normalizes the rewards within each group. So this is a group response for a one particular question. It had multiple solutions. Together it constitutes a group response. अब इसको क्या होता है? Instead of giving out absolute score, GRPO normalizes the reward within each group. So within each group, it probably normalizes the reward. इसको इतने types. It uses a simple but effective formula for group relative advantage estimation. रिवॉर्ड को देखा कि मीन से मीन ऑफ ग्रुप रिवॉर्ड्स, ग्रुप रिवॉर्ड का स्टैंडर्ड डिविएशन कितना है, तो उसमें उसकी वेरिएबिलिटी देखी फ्रॉम एवरेज, राइट. सो this normalization is like grading on a curve but for AI. It helps model understand which solution within the group were better or worse compared to their peers rather than just looking at the absolute scores. Optimization from experience. The final step, if the GRP teaches the model to improve based on what it learned from evaluating the group of solutions. This process is both powerful and stable, using two main principles to engage the model to produce more solutions like this. Moving on from that. KL diversity penalty that prevents the model from changing too drastically all at once. So स्टेबिलिटी इसलिए है क्योंकि उसने ऐसा नहीं बोला कि हाँ 3 में से तेरे को सारे मार्क बाकी सब 0, तो उसने उसको डिस्ट्रीब्यूट किया, तो इट बेसिकली नज्ड इट इन द राइट डायरेक्शन इंस्टेड ऑफ outright doing away with the solution that probably prevents model from changing too drastically all at once. This approach proves more stable than traditional methods because it looks at multiple solutions together rather than comparing just two at a time. The group-based normalization helps prevent issues with reward scaling. The KL penalty acts like a safety net, ensuring model doesn't forget what already knows while learning new things.
Sort of like gradient descent with a low learning rate. Principally वही है. Of course,
I think gradient descent.
Reward model is very different from loss function in that sense, but principally वही कह रहा है कि don't make too big steps. Of course, the fact that it is generating different attempts itself is a different thing.
मुझे लग रहा है लेकिन कि gradient descent as a back propagation method is throughout, irrespective of what GRPO है, PPO है, DPO है.
Yes.
Right, that is throughout. What I think is changing here is the that he has done normalizing of a score instead of just putting it all together. ये correct है, ये गलत है. 1-0 करने की जगह पे I think the normalization is where वो कर्व स्मूथ आउट हो जाता है इंस्टेड ऑफ स्पाइक ऐसे ये. बट आई थिंक हाँ, तो टू योर पॉइंट कि दिस इज मोर ऑफ लाइक पीपीओ हो या यहाँ हो, है करेगा तो वो अल्टीमेटली कुछ सॉफ्ट मैक्स टाइप का और लॉस फंक्शन तो होगा इसका.
वो तो अंदर तो होगा ही. This is at a much different level of abstraction.
Right, just one level higher, na. Even not even one level higher. Why would you even say that this is like the reward के पास जो, तो बेसिकली रिवॉर्ड किसने दिया, एनवायरनमेंट ने दिया. तो एनवायरनमेंट ने रिवॉर्ड कैसे दिया, वो बोलता है पीपीओ डीपीओ में तो एक मॉडल है जिसको तुमने अलग से ट्रेन किया था, वो इवेल्युएट करेगा आंसर, मतलब वो बेसिकली क्लासीफाई करेगा. तो मैं इट्स एज इफ सेइंग कि कैट इमेज का ये करेक्ट लेबल है और तुम्हारा ये प्रेडिक्शन है, तो मैं कैट लेबल से तुम्हारा लॉस फंक्शन कितना है इस हिसाब से अपने वेट एडजस्ट करो. राइट, दैट्स अ पीपीओ एंड डीपीओ. where my cat ka label was given by another reward model which again in turn was trained by me. So it was a specific job LLM जिसको लेबलिंग आता है, और उस लेबल के हिसाब से तुम अपना लॉस डिफाइन करके अपने ये करो. राइट, सो इन दैट सेंस दैट लॉस was just one level below this classification which the reward model did. In this case, it's saying it did not necessarily be a reward, it can just be a function. Right, it can be a math function, it can be whatever. Which classification I think is more spread out. I think this answer is better than this answer is better than that answer. So I think the only thing I see different is अलग मॉडल की ज़रूरत नहीं है. सिंपल फंक्शन भी, आई मीन डिपेंडिंग ऑन द कॉन्टेक्स्ट ऑफ व्हाट क्वेश्चन इज बीइंग आस्क्ड. राइट, इफ इट इज अ मैथ हेवी क्वेश्चन वेर यू कैन फैक्चुअली ascertain whether the answer was correct or not, it can be a math calculator sort of a thing कि हाँ, does the final answer tallies and steps works out.
But ये question answer तो मतलब we don't talk about it when we are training the model at all. Only at the time of fine tuning we talk,
Post-train.
right?
Yeah.
So this is replacing that process with like we were saying that there will be tokens involved which will tell it when to start, when to stop, stuff like that, right? That was the original fine tuning that we saw. Now here also there will be tokens involved.
Yeah.
At the lower level. But at an abstracted level we are saying okay, token वोकन तो ठीक है, तुम जो भी responses generate करोगे you can score the responses in a different manner versus having some of those data sets like we saw in the fine-tuning data sets we saw in the last
Correct. Fine tuning में you had an custom data set made by humans, labeled by humans, और चार चीज़ें थी उसमें. इस केस में द लेबलिंग, वो जो करेक्ट आंसर कुड जस्ट बी अ फंक्शन, कि मैंने उसको 2+2 पूछा है और इसने 2-3 प्रकार से 2+2 का अप्रोच किया और फिर ग्रुप रिस्पॉन्स बनाया और मैं उसको इवेल्युएट कर रहा हूँ. तो इवेल्युएशन के लिए नेसेसरीली मेरे पास ऐसा डेटा सेट ही ऐसा था कि 2+2 फीचर्स एंड टारगेट इक्वल टू 4. ऐसा ना होते हुए आई थिंक दैट इवेल्युएशन कुड बी डन बाय अ फंक्शन विच इज सुटेबल फॉर दैट कॉन्टेक्स्ट. राइट, वो मैथ का प्रॉब्लम है तो मैथ का ये मैथमेटिकल सॉल्वर टू रिवॉर्ड एक्यूरेट मैथमेटिकल सॉल्यूशंस. राइट, फॉर इंस्टेंस कोड का होता तो कोड इवेल्युएटर की एक इंटरप्रेटर में एक्चुअली डाल के कोड का आंसर लेके फिर कंपेयर करता कि इसमें से कौन सा आंसर सही है टाइप से. तो इन दैट सेंस हाँ, डेटा उसमें ज़्यादा लेबल्ड होने की जरूरत है, शायद ज़्यादा ह्यूमन की जरूरत है, इसमें शायद उतनी ना हो. मे बी फिर भी लगे, आई डोंट नो.
अच्छा, I need to stop here. Maybe we pick it up after an hour or tomorrow, like day after tomorrow.
ठीक है, just ping
काफी
me.
interesting है.
हाँ,
हाँ,
तो आने पे पिंग करना. If I'm around, I'll hop on. Let's do on Tuesday.
sounds good.
All right. चले.